you want to find the pH of the solution. It's very easy. All you do is to find the final hydrogen ion concentration. I taught you how to do that already. You find number of moles of this guy, then you find its concentration, and then of course you know it ionizes, and then you can find the concentration of the H plus there. So you find the number of moles, which is the mass over molar mass. That's the mass there. The molar mass of this guy is 63.02 grams per mole. That's the number of moles you have. But now you have to find the concentration of that because you're putting that in 200 milliliters of solution. Okay? And C is equal to N over V. This is N. This is your 200 milliliters. In terms of liters is 0.2 liters. And that's the concentration of your nitric acid. Now you find the concentration of H. Do your ionization equation. And you see it's a 1 mole to 1 mole. Then what do? Take this one, put it here, and you multiply by the mole ratio, 1 mole to 1 mole. And that's what it is there. And you get that concentration of hydrogen ion. And then you do a negative log of that. And this is what you get here. So when you're given a mass and a volume of the acid, find the number of moles of the acid by taking its mass and dividing it by its molar mass. You know the molar mass because you know the formula. When you get a number of moles there, you find its concentration by taking that and divide by the volume of solution that it forms, which is this in this case. Then you do your ionization equation to see the mole ratio. Then you take the concentration of the parent molecule there and you multiply by the mole ratio there, get the concentration of a hydrogen, and you find the pH of that, negative log. Calculating H plus given pH. If you are given pH, how can we calculate the hydrogen ion concentration? We know that if you're given this guy, we can calculate that guy. Therefore, if you know this one here, you should be able to calculate that. Let's say in a solution, the H plus is this, right? You will find the pH to be 1.0 because negative log of this will give you 1. Okay? So if someone says to you, look, something has a pH of 1.0, obviously, it must have come from hydrogen ion that has that concentration, right? Based on that, they've developed a mathematical relationship to teach you how to find the hydrogen ion concentration, and is equal to 10 to the negative pH moles per liter. So it'd be equal to, I say 1 times sometimes, I would say 1 times 10 to the negative 2 to the negative pH. You see, whatever the pH is, make it negative exponent. So its pH is 2, it becomes negative 2. So it's 1 times 10 to negative 2 mole per liter. So what you're having here is some questions there to find the pH. All you do is to do the ionization equation and do the mole ratio, and you multiply it by the parent molecule. This is the concentration of the parent molecule here. It becomes a little bit more challenging where they give you mass of the solid dissolved in certain liters. You go about finding number of moles of the compound. Then you find its concentration. Then you do your ionic equation to show the mole ratio, and you multiply by that, and you get it like I did before. And then you ask to find the H plus in these. It will equal to 1 times 10 to the negative 2, 1 times 10 to the negative 4, and so on. pH and dilution. If you have a pH meter in an acid, and it shows a reading of 2, and if you pour water into that, gradually you'll find that the pH will rise. So when you dilute an acid, the pH rises, okay? So look at this question here. I have 10 milliliters of this acid, and it is diluted to 100 milliliters. They want you to find a change in pH. First of all, you find the pH of the original solution, then we find the pH of the final solution, and see what the change in pH is. So we have a solution that has that concentration of HNO3, right? So do your ionization, so you get 1 mole for 1 mole. You know the original concentration. This is the original concentration, and that's the mole ratio there. So you get that number of moles per liter of hydrogen, and all you do is to find negative log. So the pH of the original solution is 2. Now we're changing it from 10 milliliters to 100 milliliters. Let us see if there's any change in pH there. Find the final concentration. Use this equation. C1V1 equals C2V2. How you can remember that? And we are looking for C2. We know C1 because they give you that 0.0100 moles per liter. You know V1, which is 10 milliliters. You know V2 is 100 milliliters. Change all of those to liters. So you leave C2 as it is there, leave this, and you bring down the V2 there. So C2 will be equal to C1 V1 over V2. This is C1, this is 10 milliliters, and this is V2, which is 100 milliliters, and this is your new concentration. When you dilute it, of course, the concentration gets less. So that will be the final concentration of your hydrogen ion. Negative log of that is equal to 3. So original pH was 2. When you dilute it to 100, it changes from 2 to 3, and there's a change of pH of 1. So note that every time you dilute an acid, its pH rises. The pH scale now, this is a pH scale. The pH scale tells us if a solution is neutral, acidic, or basic. If it is acidic, it also tells you to what degree it is acidic. If it is basic, it tells you to what degree it is basic. So watch this. Anything that has a hydrogen ion concentration of 10 times 10 to the negative 7, hydrogen ion concentration of 10 times 10 to the negative 7, in that direction, the hydrogen ion concentration gets less. You know why? Because the negative exponent here is getting less and less. We have a negative exponent that's getting less and less. It means the value is getting more and more. The lower the pH, the higher is the hydrogen ion concentration. Look, if I have a pH of 4, this is the hydrogen ion concentration. If I have a pH of 1, okay, this is the hydrogen ion concentration. So note that the lower the pH, the more acidic something becomes because the concentration of the hydrogen ion increases. The higher the pH, the lower does the concentration of the hydrogen ion get, but the OH ion concentration increases. So while H plus is decreasing like that, OH is increasing. pH paper changes color depending on the pH of the solution that it is dipped in. If you take pH paper, you put it in acid here, that is a pH of 0, it will turn to that color. If you put it in a pH that has 5, it gives you that color. Then if you don't have a pH meter, and you don't know what is the pH of this solution, put in your pH paper inside there and see what color it gets. If it turns to that color there, maybe it belongs to the pH somewhere there. That didn't choose the correct color, okay? You can see some common substances, and you can see what pHs they have. Sherry is going to be somewhere, banana here, vinegar here. Okay, stomach acid is here. Okay, very acidic. And these are the pH of some household commodities as shown here. So you look at this table here that shows you how pH changes with dilution of an acid. This is the original pH and hydrogen ion concentration, this table here. And they're showing you when you dilute it, there's a final pH. And what is the change in pH? And the number of times the solution is less concentrated in H plus than the original one. So let's do the first one as an example, right? Here you're having an acid that has a hydrogen ion concentration of 1 times 10 to the negative 1, which is equal to 0.10 moles per liter. This is in scientific notation. Put it like this, okay? Expanded form here, okay? Decimal form here. And the pH is 1. If I dilute this now to make that 1 times 10 to the negative 2, you can see that I'm changing the concentration by 10. And now the new pH is 2. So the change in pH between this guy and this guy is 1. And the number of times that this acid is less concentrated than this acid here is 10 times less. So you can see this value here is 10 times less than that value. Let's do another one. Let us say now you change this concentration of the acid from 1 times 10 to the negative 1 to 1 times 10 to the negative 3. Look, that is it. Put it in decimal form, you get this. What is this compared to that? This compared to that is 100 times less. This pH was 1. Now negative log of that gives you 3. The change in pH between 1 and 3 is 2. So every time a solution is diluted to give you a solution that's 100 times less concentrated, a change in pH of 2. If it is diluted to give you one that's 10 times less, there's a change of 1. Do another one. Here we have the original concentration. We are doing 1,000 times less concentrated. So this is 1,000 times less than that. pH here is 4 if you do a negative log. Look at the difference between this one and that one, it's 3. So if you have a solution and you dilute to such an extent that the final solution is 1,000 less concentrated than the original solution, there's a change of pH of 3. You can do another one here. We don't necessarily have to start with 1. We start with this one here. See, it's a negative 2. And we go to negative 6. So you can see this one here is 10,000 times less than that one there. pH was 2. pH is 6 now. Change is 4. So note that then. This is how pH changes when you dilute something. So as you keep diluting acid, its pH climbs, and you can know by how much it changes depending on how dilute it becomes. pOH of solutions, pOH now, just like how you have pH, same thing. pH was negative log of H plus, pOH is negative log of the OH ion concentration, okay? Again, they ask you to find the pOH of some things. How do you find the pOH of this solution here? Again, you do ionization to see the mole ratio of the OH to the parent molecule that's produced. Do it again. So here, 1 mole of sodium hydroxide produces 1 mole of OH ions. Now you want to find number of moles of this per liter. Take the parent compound there and multiply by a mole ratio here, and you get that concentration of OH there. Do a negative log of that, get the pOH to be equal to this, right? pKw and calculations. We know that Kw is equal to 1 times 10 to the negative 14. So if you do a log of this, you will get a value of 14. So pKw is equal to log of Kw, and that is equal to 14. But we also know that Kw is equal to that times that. And again, we can find what OH is. The question before, we ask you to find the pOH for this before. Now they're asking you to calculate the pH of this very solution. All right, you see how you do that. So we found the pOH of that to be 2. Now they want you to find the pH of the solution. Calculate the H plus ion concentration using the formula. In this case, I can calculate H because from this, I can calculate the OH. In the previous problem, we found that OH was equal to that. Okay, go back again to the previous problem. See, the previous problem, the very problem there, the OH was found to be that. So the H plus now is equal to Kw divided by OH. So we take what Kw is, I divide by that, and we get what H plus is. See that? That's the concentration. You see how low H is? OH is this. This is equal to 1 times 10 to the negative 2. And this one is 1 times 10 to the negative 12. We're going to find the pH now. pH is equal to negative log of this. And that is equal to 12. So hold on. In the first problem, that was OH. And when you find negative log, the pOH was 2. Does it ring a bell? That one has a pOH of 2, and this has a pH of 12. Now watch. When you add up the pH and the pOH of the solution, what does it become? 14. So in every solution, this is the equation you should know, that whatever the pH is, and you add it to the pOH, is always equal to pKw, which is equal to 14. So if you know pH, you can know what pOH is. If you know pOH, you can know what pH is. So pH will be equal to pKw, which is 14, minus pOH. pOH will be equal to pKw minus pH. All right, so if you know these equations, problem become very easy for you to solve. Another one, watch this one. What is the pH of this now? See how they're smart? They're not asking you pOH because you might say, oh gosh, I have OH. Where am I going to get H from? Remember now, if you find the OH concentration, you can find what's the H concentration. So let's do this one. First of all, you do the ionization equation. You take what you have, multiply by the mole ratio here, and this is the concentration of your OH. pOH, the negative log of that, right, is equal to this. Well, hold on. We just told you that pH is equal to pKw minus pOH. So you could very quickly find what the pH is by subtracting that value from 14 there. Go back and watch this video again, consolidate your understanding of it. What we are saying is this. Generally speaking, water at room temperature ionizes to produce these quantities of hydrogen and OH ions. You can see at 25 degrees Celsius, equal concentration is produced. Therefore, water is neutral. Anything that is added to the water that upsets that balance there will either make it acidic or basic. So what we're saying here is that at 25 degrees Celsius, because this is a constant value, we can multiply that and we call that value Kw, which is 1 times 10 to the negative 14. So a point to making, regardless if it's pure water, a basic solution, or an acidic solution, the Kw must of water stay constant at 25 degrees Celsius. Anything that increases the H plus ion concentration decreases that proportionately such that it stays this. Anything that increases this decreases that so that this stays the same. Knowing one, you can know the other. If you know OH, you can find H. If you know H, you can find OH by doing that. This table provides a very comprehensive summary of all the concepts that we have studied in this tutorial. It shows the relationships between hydrogen ion concentrations, OH ions concentrations, pH, pOH, Kw, and pKw. We'll first look at the relationship between hydrogen ions concentrations and OH ions concentrations in a solution. If an aqueous solution has a hydrogen ion concentration of 10 times 10 to the negative 2, its corresponding OH ions concentration will be equal to 10 to the negative 12. If in another aqueous solution, the hydrogen ion concentration is equal to 10 to the negative 9 moles per liter, of course, its corresponding OH ion concentrations will be 10 to the negative 5. However, in every case, the product of the hydrogen ions concentration and the OH ions concentration is always equal to 10 to the negative 14, which is the ionic product of water. So in this case, multiply that with that, you end up with this. In this case, doing the same thing, you end up with that. So always, in any aqueous solution, the product of hydrogen ions concentration, that of OH ions concentration, is always equal to 10 to the negative 14. Now we look at the relationships between pH and pOH. If a solution has a pH of 4, its corresponding pOH will be 10. If it has a pH of 12, its corresponding pOH would be 2. However, the sum of the pH and the pOH of any solution will always add up to 14, which is the pKw for water. So in this case, 2 plus 12 is equal to 14. And in this other case here, 12 plus 2 is equal to 14, as in all other cases. So look, take some time and look at this table and look for all the relationships that you can see. Hopefully that will help to remove any difficulty or misconceptions that you may have had during the course of this tutorial.